all. It's going to be a great session, very informative, and hope you all gain a lot out of it. Suva, off to you.
Wonderful. Thank you, Neha. Good afternoon, good evening, good morning, ladies, based on wherever you are. It gives me great pride to be part of the Make Tech Purple program of BayOne Solutions. And I believe this month is November, and exactly 4 years ago, we launched our data science program for women in tech. And that was also launched by Neha through our Make Tech Purple program. And we had, I believe, just over a dozen participants for that particular program. It was a 2-month-long program, and we were very successful in that. I believe almost all the participants managed to, get started in data science. That was a data science certification course. It was a hands-on, on-prem course at that time. That was just before the pandemic hit. And I believe we had 100% employment opportunity available for all of them, right? Some of them were switching careers. Some of them were returning to work moms. And the amount of effort that they put in with the help of our program, they were all very successful. So this session today is just a 60 to 90-minute workshop. It is just to get ourselves acquainted a little bit more with AI and to figure out what we need to do next in our careers to stay relevant and be successful in the months and years to come. So without further ado, I'll get started. I hope I'm visible and audible.
Yes, Suva, you look good.
Thank you. This t-shirt of mine is the closest to purple I could manage today, so my apologies there. Okay. All right, so I'll share my screen. Just let me know if you can see my screen. Okay, great. Let me go to the presentation mode. Okay, so I hope you can see my screen now.
Apologies, Suva. I don't mean to interrupt you, but we may have some folks waiting. Just
I saw that, and I was trying to let them in, and for some reason, it's not showing me that window anymore. Okay, now it is.
Yes.
Yeah. All right. Sorry, folks, for the technical glitch, but I think I'm able to switch back and forth fairly quickly. So, Neha, can you see my presentation slide now?
Yes, we can.
Okay, wonderful. Thank you, ladies, for your patience. Welcome to the BayOne workshop as part of the Make Tech Purple program on demystifying artificial intelligence. So if this is not what you are planning to attend, you are at the wrong place. But if this is, then welcome. What are the objectives for today? What is AI? Why has it suddenly become very important? Will this likely impact how we all work? What do we need to know? And how do we future-proof our careers and continue to stay relevant? Clearly, these are fairly big questions, and they cannot all be answered within the 60 to 90 minutes that we have stipulated today. But the idea is to start making us think in this direction of how to stay relevant and how we can leverage AI in our careers going forward. So we would want to make this session as interactive as possible. So please interrupt me with any questions. The idea being that towards the end of the workshop, we will have at least some time to try some hands-on experience, especially for those of us, which I doubt though, for those of us who have not used any of the Gen AI tools like ChatGPT or Bard or any of the other tools available out there. But still, we will play along, and we will have some fun doing it. So these are the objectives for today. Any questions on this? Okay, if not, let's start. 1903, Fifth Avenue, New York City, Easter Day Parade. Just look at the picture. It's 120 years old. Some of you might have seen this analogy already. But what do you see? A lot of horse-drawn carriages, right? Mostly all horse-drawn carriages. I think there is one Ford Model T, a tiny car right there, which is circled in red. But everything else is normal business. It's all horses, drawing carriages, 120 years ago. Fast forward, 1913, just 10 years from that day. Same place, same day. What has changed? Anybody would like to answer? Come on, guys. It's okay to unmute and interact. We'll do a lot of Q&A. Anyone?
There's more cars than there are people walking.
Yes, there are a lot of cars. And look at the earlier picture. Every single vehicle, essentially, was a horse-drawn carriage. What happened by 1913, within 10 years? All the horses are gone. They have been replaced by automobiles. Internal combustion engine, right? Thanks to Ford, thanks to Mercedes-Benz, you had all these wonderful cars hitting New York City. Change had already happened. If you were one of the horse-drawn carriage operators, probably you went out of business, right? Something that was probably unthinkable in 1903, but by 1913, almost all of it was all gone. This is just an example. Let's look at another example that's more recent. Anybody recognize what this is?
BlackBerry.
BlackBerry. This was the coolest device to own. Even I paid like close to $400 in, I believe, the year 2003 to buy the top of the line BlackBerry that looked something like this, almost exactly like this. This was supposed to be the coolest device. And for those of you who haven't watched a recent Hollywood blockbuster named BlackBerry, I think I encourage you to do that. It talks about their story and how Research in Motion, the company that manufactured this, was at the top of the pyramid, owning nearly 50% of the total cell phone, mobile phone market at that point in time. What happened? Came Apple, came Steve Jobs, and came the year 2007. iPhone was launched. BlackBerry disappeared. Literally overnight, their market share went from close to 50% to nearly 0%. They disappeared. Another example, electric cars. Something that only geeks would own barely a decade ago now has come to the mainstream. If you look at some of the numbers out there, barely 2 years ago, we had 500,000 electric cars on the streets. Now we have more than 1 million. It's about 7% of the total US market share for automobiles. And the projection is by 2030, it'll be nearing 30%. That is nearly 5 million battery-operated electric vehicles and plug-in hybrids. So the change is happening. The another interesting thing to note here is along with EV, there is also this autonomous driving change revolution that is happening, right? And we see all these cars driving around, whether it's Waymo or Google or Apple cars, right? Very soon you would have commercially driven autonomous vehicles out on the streets, right? Once they are able to go through the regulatory and government processes. So the essence of this is that change is inevitable. It has been happening all along. And as Alfred Lord Tennyson penned in one of his famous poems, From the Passing of Arthur, the old order changeth, the yielding place to do, God fulfills himself in many ways, lest one good custom should corrupt the world. This is a poem I had to study in high school and never quite understood the meaning of that at that point in time. But looking at these examples of transformations over the years, over the decades, I'm now at least beginning to appreciate what it means. This is the reason, ladies, we are all here today, is that change is happening all around us. And the latest major change that is going to impact you and me, all our near and dear ones, in our personal lives as well as professional lives, is the advent of artificial intelligence. A recent IBM study aptly summarized this, and they said there's a lot of scare, right, regarding AI. So IBM said AI is not going to replace people per se, right? But people who use AI will definitely replace people who don't. So just sit there, read this one more time and digest it. It won't replace people per se, but people who use AI will definitely replace people who don't. AI is a very generic use for technology, digital transformation. So for those of us here on this meeting bridge, if you agree to this, and if you've already started adopting AI and different forms of technology, different digital technologies, definitely you are empowering yourself to succeed in the future. For those of us who haven't started that journey yet, remember New York City in 1903, remember BlackBerry in the year 2003, change is going to be inevitable. So better change now than never. So with that being said, I'll dive deep into a recent survey that was conducted by PricewaterhouseCoopers. They have a very lengthy article explaining, their study of transformations and how automation is going to play a big role in the coming years and decades. But before I go there, I'll just stop here. Any questions from anyone? Okay, so PricewaterhouseCoopers talks about three waves. Wave one is essentially, and these are waves of transformation accelerated by automation. Wave one is essentially automation by use of algorithmic techniques. What it means is there are rules already existing. There's a lot of manual work going on right now, or it was in the past. And these algorithms are going to replace the manual work. That's wave one. And it's already started. Actually, it started in the previous decade. And by early 2020s, between 5 to 10% of jobs in these different sectors, transportation, financial services, and health. They have called out these three industries in particular, will be replaced, right, at the end of wave one. Wave two is all about augmentation. Augmentation is making use of existing technologies to do something better, right? Augment your regular activities. And wave three is about autonomy, that the system itself is capable of doing the entire thing, like autonomous driving, self-driven cars. Any questions on this? And it's essentially, PricewaterhouseCoopers describes this transition as, wave one in the early 2020s, running through 2022 to 23, and then wave two, which is end of this decade, and wave three is to the middle of the next decade. What kind of jobs are at risk, right? So it has looked at our levels of education and how we are likely going to be impacted. So jobs that are performed primarily by folks who have had only maybe high school level education or lower are going to be more impacted. People who have mid-level education, that is, who don't have a graduate degree, an undergrad degree, are going to be impacted to some extent. But folks with higher education will still be impacted, but not as much. So and this is an international study. I think it was conducted across 29 countries. The essence of this is for those of us who are still working, towards a degree, preferably a STEM degree, need to get that completed, right? Whether it is undergrad or postgrad, and make ourselves, future-proof as it comes to AI. And there is another element that I wanted to show to you. There is a gender bias here, unfortunately. As you can see, women are likely going to be more impacted initially in wave 1 and wave 2, but look at wave 3. There are more men being impacted in the third phase. And the reason might be there is a larger proportion of men in white-collar jobs in the knowledge domain, and that is also going to be substantially impacted by AI. We are already seeing that change, right? So I just wanted to show this discrepancy out there as well. And again, this is a study conducted by PricewaterhouseCoopers. Any questions, folks? So this basically means that almost 1/3 of the jobs as we know it are going to vanish in the next 10 to 12 years. That's a scary proposition. I was at a HR tech conference, which is the Human Resource Executive Technology Conference. It is the yardstick for the latest and greatest that is going on in the world in terms of manpower management and human resources, talking of employment and skills and so on and so forth. The job market. This year was no different. They had this conference, but there was a major change in terms of the theme relative to previous years. In the past years, they used to talk about, what are the latest gadgets and what are the latest tools and processes and ways to, make things more efficient, our processes more efficient, our employees more effective at work. This year, I saw a major shift because they started talking about things which are slightly more holistic, slightly more overarching. And these are the three chief essences that came out of that conference. Number one, companies are going to switch from external to internal hiring in the coming years. So you will see a substantial uptick in internal hiring relative to the current hire and fire kind of a cycle, right? So once you're employed somewhere, the chances are high that you will be continuously employed within that same organization, within the same company, but in different capacities, unlike in the past. Because in the past, we have all been hired on the basis of our knowledge, which is called knowledge-based, hiring. And the positioning of your job role is very specific to a particular role, right? Are you a full stack engineer? Are you a Java engineer? Are you a test engineer? Are you an administrative assistant, or whatever might be the case, right? Now, going forward, it'll be more skill-based. So you and I, we will be evaluated on skills, multiple skills across the spectrum, right? And our employers would know, and they would have ways to evaluate us across all these different skills. They would have a good repository of, who's good, who's skilled where, and they would assign us on different projects, different work assignments, depending on our expertise, our experience, and our availability. I'll just pause here for a second, right? So you're moving away from external hiring to internal hiring. You're moving from knowledge-based roles to, skill-based short-term gigs, if you will, within the organization. What does this remind you of? Can anybody think of a parallel example in any other industry where a similar kind of a model has already taken shape? Guys, please feel free to unmute yourself and
Are you just referring to the gig economy in general?
yes, gig economy in general. Yeah, that's one point. But can you think of any other examples wherein there is, you need a resource, any resource, and it gets assigned to you on demand through some kind of a platform. And the person or the thing, which is the resource, is very dynamic. So for example, if I need a place to stay, The only options I would have until a few years ago would be hotels and maybe some ads, right, on Craigslist, where somebody has rented a home temporarily. But now you have a great platform online wherein I can post my home or apartment or
Airbnb.
Airbnb. Exactly. What else? Uber, right?
Yeah, Uber,
Uber,
Lyft.
Lyft, so cars, even in computing. And I think this whole concept started with computing, and thanks to Amazon, and that was by accident. If you know the story of Amazon Web Services, they had these servers that they needed to deploy, which is hardware, right? As you know, retail, e-commerce is very seasonal in terms of demand. So during the Thanksgiving and holiday season, their demand really spikes up. So they need a lot of compute resources. They need a lot of computers, a lot of storage. So they purchased all these infrastructure and put it into their data centers. And guess what? Once the holiday season was over, came January, 60% of their equipment was sitting idle in their data center. So there was this CIO who was tasked with reducing the expense, cutting the cost. The options he was given was sell this off or do something about it. And then he came up with this excellent idea. He said, why not we loan this? Why not we loan this infrastructure to others who might need it on a temporary basis, right? And that started this whole concept of Amazon Web Services. Microsoft soon followed with Azure, and then of course Google with Google Cloud Platform, and so on and so forth. So use the same paradigm as it happened with compute, as it happened with technology, as it happened with homes in case of Airbnb, as it happened with cars or automobiles in case of Uber and Lyft and other such platforms. The same thing will happen to you and I in terms of work. You will have a bunch of skills that you're good at. I'll have a bunch of skills that I'm good at, right? And our expertise is going to be published somewhere, right, in this internal marketplace, if you will. And project managers and leaders, and we'll show our availability, and then depending on demand supply being balanced, it's all going to be dynamic. Now I'm just painting a very rough picture here in terms of what is to come, but that was the essence of this. They said, thought leaders said, whatever is happening today in compute and in automobile and hospitality is going to happen in the talent marketplace as well. So for those of you associated with human resources, with recruitment, even with sales, right, and software development in general, we will all be impacted by this. The nature of our work is going to change. The nature of job descriptions are going to change. How we associate ourselves with our organizations, with our teams, with our managers is also going to change. There would not be a fixed manager at all times. There will be multiple people who would be grading us, right, based on the different projects we did for them. And there are some companies out there, beginning with Google, and to a substantial degree, even Apple and now Amazon, they have been following this kind of a model for several years now, wherein there are resources who work on multiple projects distributed across different teams at different points in time, and they get graded collectively. Even their hiring process is based on a committee, right? A lot of people give inputs, and it's a committee-based hiring. So that's one major change we would expect to see in the world of human resource and talent management in general. Number two is, we are all aware, the pandemic came about 4 years ago, and it has impacted everything, the way we work, the demographics of the team in terms of work hours, where we work from, how we communicate with each other, things that were very synchronous, essentially everybody at the same place, same time, same location, has changed considerably now. People are contributing from different places, right? The nature of work has changed. The nature of responsibility and handoffs has changed accordingly. So that will continue to accelerate. There are certain companies which had mentioned even last year that they will have no more than 30% of employees on-prem, and the other 70% would be like a like a floating employee thing across different locales. But on the other hand, there are companies that have been asking for 100% presence in the campus, at least certain days a week, right? So there are both ends of the spectrum in terms of that. And the third part, most important and relevant to today's conversation, is the integration of all of this, of people, processes, and technologies into one big ubiquitous platform that is enabled by AI. It's going to impact all aspects of our personal and professional lives, as I mentioned. So, whatever tools you use, whatever tools I use, are not going to be separate from us, right? Nobody's going to ask you, hey, how did you generate that content? You might have looked it up on Google. You might have used some kind of an AI engine to generate some components of that. So your output is a collective product of your inputs from online resources, inputs from smart AI engines and other tools. And what you have in terms of work that you produce is this blended output, which is a product of seamless integration. Any questions? Okay, I'll continue on. So what is AI? Artificial intelligence is a technological discipline that involves emulating human behavior by utilizing machines to learn and perform tasks without the need for explicit instructions on the intended output. There's a little bit of a jargon there. I'll just pause there for a second. Emulating human behavior. The focus is on what and not on the how. That is the basic difference between traditional computer programming and machine learning. So there are different facets of AI, as the first picture at the top denotes, right? Problem solving, deep learning, machine learning, robotics, and neural networks. And you might have heard of all these things. And now, thanks to ChatGPT, things like, transformers and generative AI and so on and so forth. But let's just, disassemble all of that and simplify it to the core. For those of you who have done traditional programming, or at least are aware what programming entails, a program is nothing but a piece of syntax, right? There are some rules for that syntax, and you write that program. And then there is data. The data can be part of the program, or it might be separate. And then your program is nothing but a representation of some kind of logic, which we call an algorithm, which says exactly what to do with the data. So for example, if your data inputs are two numbers, 2 and 3, and the program is supposed to add these two numbers, 2 and 3, your output is going to be 2 plus 3 equal to 5. That's going to be a program. It's going to give you 5 as the output, right? Very basic elementary school, traditional programming. You have inputs, you have logic, you have code. It gives you the output. That's traditional programming. So how is AI different? Machine learning is a subcomponent of AI. It is a way to implement AI. And the way it is done, the basic difference is that in machine learning in particular, you give the input, you also give the output, and you give the data, and you feed it to the system. And then you say, if my inputs are 2 and 3, the output should be 5. If my inputs are 3 and 5, the output should be 8. If my inputs are 10 and 15, the output should be 10 plus 15, 25. Output should be 25, right? And the machine learning engine churns a lot of data. Input, output, input, output, input, output. And then over time, it learns. That's why it's called machine learning. It learns that how to connect these two dots. And what it outputs, in a sense, is essentially the program.
I'm sorry, I'm just a little confused by this diagram. Can I ask the output that's at the top under machine learning, the output that's at the top left there next to the data, like where is that output coming from? Is that the output?
Yes, that is okay. And
Is
thank
it
you for that question. Absolutely, good question. So initially treat that as an input. The only reason it mentions output is because it's a little bit of an iterative process, right?
Okay.
So my apologies, I'm not able to see who's asking the question, but so that output essentially, think of it more like a feedback loop. So you keep, giving more. Some of the output might go back in as the input, and then you churn it over and over again. But that's just ignore that part. Assume that's input for a second. I hope
Okay,
that,
yeah. Thanks for clarifying. I appreciate that. And it's okay.
Absolutely. But the essence of this is, for people who are new to AI in general and machine learning in particular, the most difficult concept to understand initially is this concept as to why does it get very complicated initially when you are writing, machine learning, when you're creating these models, and why do you have to go through so much detail? And why do you need to focus so much on data and iterations and all these things, right? And this is the reason why, because in order to create that, algorithm is not a term I should be using, but just for a second, let's assume the output, the program is in the form of some kind of an algorithm. For the machine to be able to generate that algorithm, it needs a lot of data, right? Because giving you 3 and 5 and expecting 8 as an output, you can have infinite number of computations using 3 and 5. Addition is the most simple, but you can have many other computations possible, right? By the virtue of which you'll still get 8 when you have 3 and 5 as the input. That's why it requires a lot of data. Hundreds, thousands, millions, and for a complicated model, probably a billion data points. And even then, unlike traditional programming, which is very rule-based, traditional programming, you give inputs 3 and 5, it'll always give you the output as 8. Because you have the logic there. You've already written it in the program. It will never give you 7 or 9. But machine learning could potentially give you a slightly different output because it is all probabilistic. It is not based on a set of assumptions. So what does this mean at a very high level? Problems that require a solution where the logic is very simple, very clean. Addition, subtraction, basic mathematics, basic statistics, right? We use traditional programming. You cannot have AI do that. Although AI today, unfortunately, in the media and the general world, whenever people refer to AI, they mean everything, including programming and automation and everything, right? But in the strict term, AI refers to only those elements which are emulating human behavior and are based on this kind of a logic that I just mentioned. So you can think of it as slightly different than traditional programming. Any other questions? Okay, I'll move on. So think of AI as this overarching thing. Machine learning is a subset of that, right? Deep learning is a subset of machine learning. And now the latest, natural language models and all the generative AI that's going on above that is consider that as a subset of that, right? So when people are talking generative AI, automatically it implies that it is a component of deep learning. And by virtue of that, it is a component of machine learning. And by virtue of that, it's a component of artificial intelligence, which basically means all the rules that apply to AI apply to machine learning and to deep learning and to generative AI. But all the rules that apply to generative AI may not necessarily apply to deep learning and vice versa, right? Because it's just a subset of that. And I'll try to explain at least some of the foundational components, what each of these layers mean going forward. Any questions? Okay, let's take an example. Sorry, ladies, this is a little bit technical, but hopefully you'll like this example. In 1969, there was a model for a perceptron that was proposed by Minsky and Papert in a technical paper, but it took several decades before this became mainstream, right, when AI took over. Think of this. Look at the house on the left, right? And assume we are all real estate agents, okay? Assume we are all real estate agents, and we have to price this house. assume, I'm going to sell, I want to sell my house, and you all are real estate agents. You have to propose to me what should be the asking price for this house. So please feel free to unmute yourselves and suggest to me what factors would you use to consider how much the house should be priced at.
I'll jump in. That would be size, location, number of bedrooms, number of outside area, square footage, amenities, and other features.
Absolutely wonderful. Absolutely wonderful, right? So there isn't just one parameter. There are a bunch of parameters, right? So you will take into consideration all of that. And at the end of that, you're going to tell me, please choose a number. Let's price the house. What would be the price? Let's assume it's a 3-bedroom, 2-bathroom house here in Pleasanton, California. How much would you price it at? Just pick a number.
It's in Pleasanton. Let's start at like 800,000.
Wonderful. I wish if you were selling, I wish if I could buy it from you. That's very optimistic for Pleasanton. But yes, let's assume it's 800,000, right? Let's assume it's 800,000. Now, if I were to ask you, how did 3 bedrooms factor in? Although you told me that 3 bedrooms and 2 bathrooms and square footage and location and lot size are all important. But now there is another house, let's say my neighbor's house, and even she wants to sell that property, right? Which is also another 3-bedroom, 2-bathroom house. Maybe some of the other parameters are a little different. And let us say she wants to price it, her real estate agent wants to price it at 750. Now, do we know how much weightage the bedrooms should carry? How much weightage the bathroom should carry? And all the other parameters. And there might be a myriad number of parameters, right? Do we have a definitive logic to this? Or is it mainly intuitive? Question for everyone. Do you think it is going to be based on a very rigid set of rules, or is this all going to be a little intuitive?
Seems like it would be.
Intuitive, right?
Women is that we don't like to interrupt each other, so it's going to be hard to have us all
Go ahead.
I think we were both, a couple of us are trying to say intuitive at the same time. It seems kind of intuitive. It doesn't seem
Yes,
like simple
yes, it does. It does. And that concept is called inductive reasoning. And that is all about correlation. And that is what all the Greek philosophers, the Aristotles and the Platos, during that time, this is the kind of logic that was followed. It was all based on evidence, right? So that house down the street, 3-bed, 2-bath, sold for, $850,000. Now the market has gone a little soft. So today it would sell for 800. My neighbor, similar house, maybe 1 or 2 parameters are a little different. That's why they priced it at 750. Inductive reasoning. There is no direct logic to it. There are some factors. There is some correlation. It is by induction, not by deduction. However, came Isaac Newton, right, few centuries ago, and this whole renaissance of science and physics and mathematics, and a lot of things changed in this domain. And they started the concept, or they pioneered the concept of deductive reasoning, where someone comes up with a hypothesis, then lays down a proof, and based on that proof, a formula is generated, right? And there are, like example, gravity, force, F equals G times, M1 times M2 over R square, and every symbol there has a value. And then you know exactly that force is mass times acceleration. And whether you are measuring it here or in Italy or some other planet, it will exactly be the same. It doesn't change, right? So that is deductive reasoning. Traditional computer programming is all based on deductive reasoning, where the rules are very rigid. Yes, I think there was another question.
So is a perceptron based on inductive or deductive?
Yes, exactly. You got it. It is based on inductive. And that is why in a perceptron, in inductive reasoning, what you do to calculate the price of the house, you provide all these inputs. We just provide the inputs. And you say, this house has, how many bedrooms, how many bathrooms, and you put in as many attributes of the house as possible, including, the color of the house, the location, the direction it is facing. And who knows, the direction of the house might be a significant contributor to what the price is going to be eventually. You never know. So what you do is you plug all these things in, and you have the historic data, right? You collect data for the last 10 years, 15 years, 20 years in your county. You put all these attributes in for every single house that's sold in your zip code, and you know exactly how much you sold it for, and you feed it into the perceptron. What does the perceptron do? It looks at, let us assume there are 100 attributes to the house, like bedrooms and bathrooms and location and blah, 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 school district and so on and so forth, right? What it does is it assigns random weights, W0 through Wn, combines them together, applies some mathematics, what is called as a step function. Don't worry about that. But then it then predicts, okay, I think the price of this kind of a house should be 200,000. Was it 200K? No, it was 850. So then it has to correct itself, right? And the way it corrects itself, and that's why you saw the output and input sort of going back in there, is it has to run this model now 10, 15, 100,000 million times across all the different homes that are sold in your neighborhood in the past 10 years. Now tell me, once it has sampled through all the million or at least a few 100,000 records for your county, do you think the weights that need to be associated, and it keeps correcting itself, right? Correcting, adjusting. By the time it is done with the millionth iteration, what are the chances that the weights it has assigned for each of these attributes, do you think it's going to be fairly accurate or not? Very likely, yes.
More accurate, right?
Very likely, yes. This is not a science. Again, it is not deductive reasoning. It is inductive. In all probability, it is going to assign these weights. And now you have my house that is coming on the market, and I input these exact parameters, say 100 parameters. The model is going to tell me, based on the data from the last 20 years, looking at these 100,000 sales, most likely this house is going to sell for blah. And let us say that number is 798,000. Is my house going to sell for exactly 798? Not sure. But if we take 10 homes that are on the market today, or 15 homes on the market today, and the model is going to predict for all 15 based on the last, several decades of information. If you look at it holistically, it's going to be very accurate, 99.99% in terms of what the collective values of these homes are going to be. You'll still have aberrations. Individual homes are different. There is no logic. It is not deductive reasoning. There is no science to it. Every home is different. These are the kind of examples where AI does come into play. This is the reason why Zillow, even today, continues to have open competitions to keep improving its pricing model. And for those of you who remember, who have been active users of Zillow over the last several years, the Zillow pricing, online pricing on pieces of property, especially in the Bay Area, was ridiculously bad, even until a few years ago. They were all over the place. Sometimes over, sometimes under. But now they're fairly accurate. It's very real time. Their data keeps, they have a lot of data. They have access to more and more data. Their model keeps improving because they're constantly, iterating. They probably know exactly all these weights. They know the sentiments. They're probably looking, the input parameters might not just be these. It might be what was published in the newspaper yesterday, right? What is the political climate in the Middle East? Where do we stand on global warming today? There might be so many exogenous factors that are also implicitly contributing to the model. And as you keep adding these additional attributes, the chances of it being more and more accurate are higher. The only problem is it requires a lot of compute power. It requires a lot of data. I'll just pause here for a second. This concept of a perceptron This concept of assigning different weights and dynamically determining the relationship between the attributes and the weights and be able to predict something is the essence of all of machine learning and is at the heart of all of neural networks. A perceptron is nothing but the building block of a neural network that goes into building all these models, including large language models, including generative AI, which is at the heart of ChatGPT. So my apologies for taking a little long here, but if you get this concept, you will understand and be able to appreciate how most of AI works.
I have a question.
Yes.
With this concept that we were just talking about. So just looking over during the pandemic years, how does AI compute the issue? Like when during the pandemic, housing went sky high. They're now coming down, but because people were trying to buy in different areas and it was a very unusual situation, how does it adapt to that? All I can think of is a strange concept of how those housing, I know we're just talking about housing, but I'm just thinking, in everything that we do, there could be that strange period that in this instance, housing, I mean, just in my area, I live in the northeast, and housing here was outrageous. And they've come down some, but because people were trying to buy here, because it was still cheaper than people in California, and the job market switched from having to be in a brick and mortar versus being able to work from home, people were moving across country. So it was just an odd time. How would that make that adjustment?
Yeah, absolutely. And thank you for that question, because it covers, 2 or 3 very important facets to today's conversation, right? First of all, where I started off with, the nature of our jobs and the way we work and how we work and where we work from has changed. And probably to a large degree, it has changed forever. So that is going to stay with us, right? A lot of my, co-workers, they moved to Idaho and different places in the Midwest because they found more affordable, options, and they were closer to some of their extended family members, and that was their preference. And, they decided to move, and they're enjoying it right now. Some of them have since actually moved back because they did not find this remote work that fruitful, but others chose to stay back, right? So there are all these cases. So that's something we all need to keep in the back of our minds, because that is going to impact the nature of our work and how we interact with colleagues and all that. But to your point, these models are completely blind. They are not subjective at all. They're completely objective. Now, your question might be, yes, a lot of aberrations happen. Market goes up, market goes down. And that's exactly what we talk by inputs, right? So essentially, in your inputs, you have to provide all these things. How is the overall economic climate? How is the overall, is there a pandemic out there? What are the latest news headlines? Whatever you can throw into the model in terms of input parameters you throw in, because now compute, thanks to the silicon getting cheaper and cheaper and cheaper, is now ubiquitous, right? Even the most powerful servers on Amazon can be rented for a few cents, and you pay, you use, and then you let go, right? So all of these things that you talked about, right? All these aberrations can also be sort of fed into the system, but not programmed. That is the difference. I cannot tell the system, hey, because of the pandemic, the prices are going to go up. Or, now that, some other rules have come into place, the prices are going to go down. The interest rates have gone up, the price is going to go down. No. All I do is just provide the data. The system looks at that data and makes a determination, right? All you have to tell the system is June, because we are talking the entire data, including historic data, right? So we give the system as many parameters as possible, 100, 1,000 input parameters, zip codes, interest rates, even, the most ludicrous of parameters like the color of the house, the paint,
and so on and so forth. Even whether the window panes are frosted or clear, you will be amazed how some of these seemingly nonsensical sounding attributes sometimes play a substantial role in the price of the house. So the moral of the story here is a perceptron is a building block of an AI engine, which is a unit of what is a neural network. And unlike a traditional program, wherein you provide the logic, in this case, all you provide are the attributes, right? And you provide tons of data. And all you say is, when the input was this was the output. So for all of these things as input, the price of the house was this. And you provide 1 million such data points. All the home sales since, say, year 2000, whenever you have the records from, right? The system churns through all the data, identifies the weights, randomly keeps changing, runs the model over and over and over and over again, millions of times, until it gets to a point that it is able to predict with, say, 99.99% accuracy that most likely, given these parameters, this should be the price of the house. And one important distinction I just mentioned a few minutes earlier is that that still does not guarantee that that will be the price of the house. But for a collective set of data points, it will be fairly accurate, because at an individual level, you will always have exceptions. It is like, my kid is in high school, I provide all the attributes, and the system has to guess how much my student is going to score in a particular test. Is that inductive or deductive? It cannot be deductive, right? There are 1 million parameters, and there is no function, there's no logic to it. But it's inductive. That, last month she scored, this much, the month before that, she scored that much. Last time she studied 10 hours. This time she studied only 8 hours, and so on and so forth. So very likely she's going to score this much. It's all based on inductive. So this is what I feed to the system. System comes up with weights, makes an assignment, and creates the model. I just go ahead in the interest of time. So now you have a perceptron, which is a single building block, and now you throw that into a network. You have similar multiple such building blocks. You combine them together, right? You look at this thing at the middle where I have, the area of the home, number of rooms, your zip code, even, a factor of wealth in terms of, the neighborhood, the school district, and so on and so forth. You keep combining these different factors in different ways and forms. And then eventually the system internally comes up with that logic of how to, combine them together by assigning weights, and is able to determine a price. And initially, like I said, the determination is pretty bad. It might only be 50% accurate, right? And as it runs over and over and over again, it starts getting more and more and more accurate. So all the inputs that you provide originally is called an input layer. The system itself now starts combining different things and creates its own input parameters. That's a very interesting concept in a multi-layer neural network. Okay, those are called hidden layers. What that means is you have provided the zip code, you have provided how wealthy your neighborhood is, you have provided how good the roads are, right? And based on all of that, maybe it internally combines these things and comes up with a parameter which is a combination of this. It is all mathematical, but comes up with an additional parameter which is like walkable, right? How walkable is the home from the school? How is the school quality, right? How much is the family size? And maybe family size is based on the area and the number of rooms and all that. So again, this is all mathematical. It's happening inside a computer. The computer cannot distinguish between family and walkable and all that. But the concept I'm trying to tell you is you have given the model a bunch of very disparate parameters. It looks at each of those individually and also begins to gradually combine some of those parameters and starts looking at them as groups of parameters, which we are calling as hidden layers, and then combines everything together holistically, and then comes up with this output, which we call the output layer, which is the prediction of the price. And the output could be anything, right? If it is a self-driven car, the prediction could be, hey, is that object in front of me hazardous or not? If it is a recommendation engine, it could be, I bought something on Amazon. What should be the most recommended product for me that I'm likely to buy next, right? I have just given you an example in the housing thing because it's very relatable. Determining the price of a house, but it could apply anywhere and everywhere wherever inductive reasoning doesn't work, or sorry, where deductive reasoning doesn't work but inductive reasoning does. Any more questions here? Okay, so let me step forward, right? So what we looked here was a multi-layer perceptron. There are these multiple layers that have made a prediction. In machine learning, the attributes of an object, like let's say in this case a car or a house, are called features. Engineers actually sit down and determine what those features are. And typically, that is what traditional machine learning means. So you identify, okay, if this is the house, then most likely I think these are the parameters that need to be considered, right? As a real estate agent, I think I know what are the parameters. I feed it into the system. I make life a little easier for the model, and it undergoes what is called as a classification thing, right? And then, okay, this is a classification example. And then it tries to determine whether the input is a car or not a car. Now, there is another concept called deep learning. So I just wanted to underline the difference between machine learning and deep learning. In the case of deep learning, there is no feature extraction. What that basically means is there is no interim person, right, or step that provides any additional inputs into the system. So all you do is take the raw data, feed it into the system, and then make the system determine. Let's take an example. I'm trying to classify images, right? I have images of pets, and say I have 1 billion images. I pick them all up from Google. And all I need my system to do is be able to identify, is this a cat or not a cat? Right? Now, machine learning would have entailed that in addition to providing a picture of a cat, because I have to provide the data so that the system learns, right? I would provide the picture of a cat and then also additionally say, cats typically have ears and eyes and nose, and this is what an eye is, this is what are ears, these are whiskers, and this is fur, and this is blah, blah, blah. Those are features. I would have given additional inputs. And then hope that my machine learning is able to, then determine whether it's a cat or not, right? In deep learning, I don't do that. I just provide a picture, I say cat. I provide another picture, I say not cat. Cat, not cat, cat, not cat. I provide 1 million such pictures. The system does its magic, its generation of weights, the core of which is a perceptron, like I mentioned right now, right? This is very simplified, guys, by the way. The actual thing is a lot more complex than this, but at a very simplistic level, that's how it works. And then over time it learns, and then you have, your image, which is 1,000,001. I show it, and it's able to say cat, not a cat. By the way, today, as of now, AI is able to classify animals much better than human beings. Even sub-classification and sub-classification of that, I think starting, circa 2018, the errors done by human classification now is higher. Even subject matter experts, cause higher error than a machine-based classification, which is based out of deep learning. So I hope this explains the difference between, at a very high level, difference between machine learning and deep learning. Deep learning requires more computation, as you can see, more layers, because there is no feature extraction. We are not providing the system any cheat sheet in a way, right? So it's a lot more expensive, but the reason it is possible is because compute is substantially cheaper now than what it was earlier. So, any questions?
Suva, there's some questions or maybe comments in the chat.
Okay.
Some of them are comments. I think Samya's checking in if they could get a recording of the session.
Yes.
Okay.
Yes, the answer is yes, we will do that, and I'm able to view the comments. I think I'm sharing my screen so everybody is able to see it. Yeah, it still needs a lot of data, a lot of training, what to do with that data. Yes. Perhaps the weights. They require humans to update the input. Okay, humans, to Nicole's question, humans do not update the weights. Humans just keep providing the data, right? That's why it's called, there's a concept called supervised learning, right? Machine is a machine. Machine randomly picks weights. And that's why it tries multiple times, You have to be patient. It's unlike our children. We teach them once and they are able to figure out, right? But a machine is going to randomly guess. It keeps random until it starts hitting closer and closer to 100%. And that's when it knows that now its weights are clear. That is the essence. The minute you think that you are assigning the weight or the programmer is assigning the weight, you are automatically thinking deductive reasoning. You are thinking traditional programming. And that is not how it works. In AI, we have no idea what the weights are. In fact, there is zero transparency. There is, in the realm of AI, you might want to Google this, there is this issue of explicability, right? Is the rationale behind an AI engine's decision explicable? As in, can it be explained? In many cases, the answer is no, because it's not going to tell you how and why it chose a particular decision. Why did it decide that this was a cat or not a cat? You cannot go inside. There is no algorithm, right? There is nothing to invest. It looks at the past data, it uses the weights, and it says, yes, cat, no cat. It cannot tell you why it decided either ways. And that is an issue. In certain professions where you need to understand the rationale, it's a self-driven car, you are hitting a T-junction, you need to make either a left turn or a right turn, right? And there is an AI engine sitting inside your Tesla that needs to make a rapid decision. Should I turn left or should I turn right? It makes a decision, but it won't be able to tell you why it took that decision. So there is some element of ethical dilemma there. I'm just reading through the comments. Okay, so let's go back to the presentation. We are just about at the 5 o'clock mark, or just over that. I'll try my best to wrap up in the next 30 minutes or so. We might go a little over, given we are barely scratching the surface right now, but I'll try to speed up my thing. So now I think I'll not pause for questions per se. Please feel free to interrupt me. Okay, so all right. So we learned about machine learning, we learned about deep learning and how they are different. Generative AI is essentially a further subset of deep learning. That can produce new content, right, based on the input, and I think many of you have already started using it. And it can produce language, as in text. It can produce computer code. It can also produce images, as many of you might have already seen. So again, the same framework of superset and subsets, but with a little bit more detail. Okay. And generative AI, there are GANs and there are LLMs and so on and so forth. GAN is nothing but a generative adversarial network. I hope to conduct some kind of a workshop in the future with a little bit more detail for those of you who are interested. We can look at some of these elements a little bit more detail. So large language models, the way they are done, all models, they function in the same way. There is tons of data pulled from different sources, say the internet. It goes through the process of what we call as training. What I showed you in a perceptron and the identification of the weights is nothing but how the model gets trained. The model is a lot more complex than the perceptron I showed you. Perceptron was just a unit. We just combine them together, multiple layers. And again, there are different kinds of models, convolution models, recurrent models, models that are optimized for visual images, models that are optimized for what are called as time series, models that are optimized for text, natural language, right? Every model is a little different. And then, of course, once you have the model available, you apply that into different domains, you adapt it, and you can have a myriad number of applications stemming out of it. I'm just a quick snapshot of the generative AI landscape. You might have heard of ChatGPT and Bard, but there are a lot more other players as well. There are companies like NVIDIA that are providing these GPUs where you can have these very intense, high volume, processing that is required for massaging this kind of data, right? And then, of course, a lot of the infrastructure is available on AWS and Azure. And then there are these layers as you go from the left to the right. You go from the bottom to the top of the application. This just gives you a very high level snapshot of, what some of the players are and where they stand in the ecosystem. Okay, I'll continue on. AI terminology, right? If you look at the same concentric circles, now let's go a little deeper again. AI, machine learning subcomponent, deep learning, Gen AI, and then, pre-trained transformers, generative pre-trained transformers are a subcomponent of Gen AI. Large language models are sort of a subcomponent of chat. GPT-4 is an implementation of that, and a chat GPT is a commercially available version that has been provided by OpenAI, right? So imagine these as concentric circles. I just, found this on Twitter, so I thought maybe I'll share it with you. It's not very pretty, but at least it drives home the point that, one is a subset of the other, or a specific implementation of the other. Okay, I'll continue on. Now, in terms of how we have progressed over the last 20 to 30 years, is that whenever we talked about intelligence in general, initially the intelligence was all about aggregation. I provide the computer some data, and the computer is able to describe back to me what it means. That was simple data interpretation, what we call as descriptive problems. And that genre started sometime in the 1990s and continued through to the late 2000s, right? It's all descriptive. So tools like, you have Tableau and a bunch of other tools, newer tools as well, that came about that had these beautiful visualizations, right? And that is all descriptive. It is all historical data, right? You have a database or what is called as a data warehouse that has historical data. You build beautiful graphs. That is descriptive, right? Gradually, as AI started to, enter into the ecosystem, and as you had more data, as you had these inductive reasoning capabilities, you had the concept of predictiveness. Example, the price of a home. Never in the past could you predict. But now, thanks to our friend, the Perceptron, and the extrapolations from therein, we were able to fairly accurately predict something, right? And this thing started particularly with Microsoft, which spearheaded a lot of things in the AI space, coming up with very strong predictive models, and that took shape. The last few years have been all around being prescriptive. And this is the age of Gen AI. Okay, I have the data. I'm able to present it. That is descriptive, right? I have the data from the past, and based on that, I can predict what is most likely going to happen in the future. Great, that's where we are now. Now, if the system could tell me, if only I change this, if only I change the color of my house, I cannot change the direction of my house, but I can change the paint, right? I can change the landscaping. The system can tell me, don't worry too much about your kitchen upgrade. You're going to spend 50 grand. It's not going to give you that much return. But if you're going to do this, then your ROI is going to be much higher. That's like, wow, for me. Real estate agents today are able to do this through sheer intuition. But the state of the art would be when there is software available, you put all these things in, and for your home in particular, it'll say, all you do is change these two things. You are going to get a 5% premium. That's prescriptive.
So quick question about this, just to be very clear about the shift from data-centric to action-centric. The thing that's being shifted is our approach to this, or the actual technology itself?
Both. That's a very good question. That's a good question, right? So we did not have the capabilities to do that. So the kind of solutions that are out there in the market would focus mainly on data-centric solutions. It was all about, just roll back 20 years, right? Everybody was talking dashboards. This dashboard, that dashboard, everybody wanted to have a dashboard. Why? Because until then, this concept of a universal view, right? A view to whatever is happening in your company, in your data center, or whatever it might be, was never available. So the first generation BI tools came up with very descriptive solutions. That was the state of the art. The next step in that progression was predictive. And now, of course, we are trying to be prescriptive. So these are the, So the data remains the same. Data is the foundational element. the building block to all of this. What this talks about is our capability. What
Right.
kind of tools do we have now using which we can do these things?
Okay, so to give it just a quick real world example, I'm sure many of us are in the throes of or recently in a job search. So the descriptive the descriptive aspect of that was, okay, here are the jobs that are available, and then the predictive would be, here are the jobs that we can expect to see in the next year, and then the prescriptive would be, based on what we know about what's available and what we're predicting for the next year, this is how you should prepare for those predicted future jobs.
Absolutely, yes. I will even take that baton and pass it forward and say, in fact, the intent was to cover some of these things down the road, was that I met a gentleman yesterday who said that, now the way he applies, for different jobs is completely changed. He has what he calls as a very generic text-based resume. And then he looks at the job description, he goes to ChatGPT and then writes a beautiful, what is called as a prompt, and says, this is the job description. This is my current resume. ChatGPT, my friend, please help me craft a cover letter and enhance my resume, right? It does not mean lie anything there. It means present my credentials in a way that is more appealing to that job description. Because remember, majority of the job applicants are filtered out automatically by an ATS tool that is sitting at the edge of their ecosystem. Most people don't realize this, but a badly written resume of even the best of candidates gets immediately rejected because it doesn't have the right things that the bot is looking for in there.
Right.
In fact, to the extent that there was a substantial gender bias in many of the Microsoft screenings that was happening a couple of years ago, and you might have read about that, infamous news, right? That came about because they were caught in that they were, showing a substantial bias towards a certain gender, and then they realized, oh no, this is causing a gender bias, and they had to stop using that. So the fault there was not necessarily of the AI engine, but the way the data was being fed. So a lot of us who will be working in the AI ecosystem need to ensure that whatever data is being presented to the system is also unbiased, or at least have techniques and methods by which we eliminate and reduce bias. And I'll touch upon that as well. Okay, so there are some examples of, Gen AI. ChatGPT, we all know. DALL-E, probably many of you have heard about, and there are a few others as well. I will go through this very quickly. ChatGPT, was launched late 2022, and then it just took everyone by surprise. It grabbed the majority of the market share. That is still the case, and there are a few other players in the space as well. And depending on which domain you work in, there are a lot of specialized tools out there. So we'll talk about that as well. One major parameter in terms of adoption is how many users a tool or a product gains over a short span of time. And just look at this. Netflix in 1999 took 3.5 years to reach 1 million users, right? Guess how long it took ChatGPT to reach 1 million users, as you can see here. It's unbelievable. I would have guessed it was like a month, but it's actually 5 days. Is all it took for ChatGPT from the day it launched to have 1 million users. Isn't that amazing? And I had another graph here, but I think I've lost that. Okay, so and it reached 100 million or so shortly thereafter, but I think I have that graph somewhere later down the road. Okay, so Gen AI adoption, it's very heavy across the board. The Indian subcontinent has 73% usage now. Salesforce last week, and this is a fairly new survey, surveyed close to 5,000 IT professionals globally. And these are the numbers coming out of that survey. Now, the survey sample was fairly big, like I said, close to 5,000, but it's still not representative of the 8 billion people we have on the planet. But it will still give you a rough idea of how the different populations around the world are using it. As you can see, Indian subcontinent, Australia, US, between 40 and 70. In the UK, you see the number is a little lower, 29%, but that partly is also because of privacy policies and some restrictions that the EU already has in place, along with the UK as well, in terms of what is considered personal data and private and all that. And many of the corporations may not have the flexibility to use open chat GPT because of leak of proprietary information. Some of you might have also read that Samsung recently barred all its employees from using ChatGPT because guess what? Many of their engineers were going to ChatGPT, submitting their design, proof of concept, and asking ChatGPT for inputs. So guess what? ChatGPT doesn't cheat, right? I mean, it's very fair. But as that data was being provided, it was learning. And if there was somebody else from some other competing, a company like say Sony or somebody, and accidentally the data would get leaked because ChatGPT wouldn't know that this is proprietary to Samsung. So now what many companies, corporates are doing is that they take the ChatGPT or whichever Gen AI platform, and then they customize it, right? Or they implement it within their firewall for their use, for their employees only, right, within their organization. So that information does not get leaked outside. And there are many providers, again, that provide such customized solutions. So again, I'll just move on to the next slide. But the core to remember are the last two bullets. 67% of IT leaders globally have prioritized Gen AI for their business. So for those of you on the call, if you have very little of AI exposure, this is time to think about it. Right? We have to make ourselves a little AI friendly and at least be able to speak that language. And 33% of them said that it was top priority for them. So your resume, at least in some shape or form, should spell out the fact that you are conversant with AI, right? In whatever role you are working on. How is AI being used right now? Generative AI in particular, for those IT professionals, content creation. A lot of people in content creation, digital marketing, outreach, sales, they're relying a lot on Gen AI now to come up with creative ideas, how to create content, creating copies of existing content, right? Creating different variants to do A/B testing, multivariate testing, and analyzing data, creating new images. And I'll show you some examples of very creative things you can do with some of these tools, generating reports, and so on and so forth. 71% expect that Gen AI will eliminate busy work and allow them to focus on more strategic work. This was the core of the survey. And recently Gartner conducted another survey of majority of salespeople in the US. And they predicted that close to 27% time is going to be freed for many of the sales executives to focus on more value creation. So these are the 10 ways, for example, you can use generative AI in financing and accounting. Again, this is just an example. You can read documents, you can create reports, you can improve customer experience, you can have fraud detection by looking at patterns and see how it is different, right? Computers are really good at catching patterns which humans cannot. Automation of repetitive tasks. Of course, there is this entire bot component, right? Targeted personalized communication. Earlier, that was not possible, even with outreach tools. But now, like Mail Merge and MailChimp and all that, you still have to type the text, but now you can personalize it. I know that Amy likes this, so I can craft it in a different way. I know that Neha, prefers some other thing, so I can craft my outreach in a slightly different way, and so on and so forth. So it becomes very subjective. Okay. So here is that slide. Unfortunately, I think it shifted down. It took 2 months for ChatGPT to go from 1 million to 100 million users. That is 100x multiplication in from 5 days to 2 months. So that is like 7 weeks. It's amazing, right? And just look at the guy on the left. Let's say Netflix, for example. It took them 10 years. Just imagine the order of magnitude, moving down from 10 years to just 2 months to reach 100 million users. Amazing, right? Talk of viral effect. I don't even think the pandemic spread at this level. So there are a few slides I have here based on the recent study of Gartner, and I will be sharing it with our event organizer Neha. And if you need a copy of this, we would be glad to share it with you. But it talks about, if you're in the sales organization, how you can leverage AI in general and Gen AI in particular to be more effective in your sales activities. So it talks about allowing, treating technology as a member of your team, not treat it as an outside tool, right? It is seamlessly integrated into your ecosystem, and then to focus on things that matter the most. And it gives you a breakdown of how much time was spent in different sales activities on the left historically versus how some of these newer technologies are going to make you more efficient and effective in some of the other areas that is going to spare you almost a quarter or more of your bandwidth so that you can devote that into additional value creation. And it goes into the depths of how you should start, where you should start with automation, then assisted selling, then automated selling, and then autonomous selling. So there is this whole concept of product-led growth and all those things, and how machines and bots become an essential part of that ecosystem. So, but I won't dive into the details of that. We would love to share the presentation with you later, and then you can look into how some of these transformations come about. So your AI engine is moving from being a tool to being a teammate, right? And likewise, I said at the beginning that our work ecosystem should not be seen as a disparate set of entities, but a seamless integration of, full-time workers, gig workers, machines and bots, and we are sort of collaborating and communicating with each other to create, value-added services for our clients. And this talks about the transformational journey from problem identification to supplier selection when that happens. Okay. I know this was a little fast, the last few slides, but it's more of a self-read, which you'll be able to do. I will now focus a little bit on AI in software development. I think many of you ladies probably have something to do with software, even if it is not necessarily product development. It might be, product engineering. It might be quality assurance. It might be, on the infrastructure side, DevOps, and even for those of you who are not directly related to software, at least this will give you an idea of the kind of use cases that would apply potentially in your domain as well, right? So what does this mean? Very quickly, AI has almost already become the foundation of all software, including software delivery and development. It has become, more of a utility, right? We are evolving from design thinking to platform thinking. That's a major shift. AI is going to help us rapidly build and deploy proofs of concept. So you can have more iterations of your solution, whether it is a website or a tool or a device. You can create more prototypes more quickly. AI is going to help you do that. And you can deploy fully tested applications on a real-time basis. The AI engine, if you will appear in many forms. What is AI? It can be seen in the form of a bot, like a humanoid, but those are probably just 5% of the use cases, right? It might just be a suggestion. It might be a spell checker. It might be a companion bot. It might be an engine that runs analytics on the back end. It might be in your Gmail app, for example, whatever was, doing a check, a spam filter check, or a security check on your emails. Earlier was probably based on just logic, right? It had some checks, right? Very deductive logic. But now maybe there is an AI engine that is sitting there that we don't know. And maybe that is why Gmail is effectively able to flag more emails as, suspected spams or a potential virus and so on and so forth. If you are a business analyst, your role will be elevated to a business strategist, because now you can leverage AI to write your user stories, create your requirements, define the acceptance criteria. So you are getting more bandwidth and you are able to sort of move away from the mundane task of just crunching numbers and building graphs. But instead, you will be assessing ideas, right? Driving business alignment and looking at ways to collaborate with other teams. And likewise with interaction design roles, and also with software architects. I think software architects are now very happy. Earlier, they had to spend many hours intricately building systems, right, and drawing it out and all that. Now you just type it out. The system actually builds it for you. We'll show that hands-on. I'll show you a few examples on Bard and ChatGPT, how this can be done. Technology landscape for AI covers multiple domains, from neuromorphic computing on the medical side to machine learning, deep learning. We talked about that, chatbots, and you'll see all these myriad number of applications. So I'll stop in just a minute before I take questions, and then we go hands-on. What are the AI skills in demand today? Okay, this is a slightly exhaustive list. So many of you in this room today may not be directly associated with some of these technologies, but if you are at the cusp of a change, and if you are looking to move or at least learn something new, these are some areas which you can start exploring. Okay, machine learning, deep learning, natural language processing, computer vision, reinforcement learning, data science. At least to begin with, just Google these terms. Try to understand what they mean. Basic statistics and big data technologies, cloud computing, natural language generation, speech generation, time series. At least you need to understand what is a time series. Recommendation systems, AI model optimization, ethics. I think one of you asked about whether AI can be trusted. So yes, ethical component is going to be major. You'll probably have an entire team that will be looking into ethics in an organization. So yes, if we were to connect the dots, at the beginning of the call, I mentioned about that PricewaterhouseCoopers survey that predicts that 1 out of 3 jobs are likely going to be obsolete in the next 10 years or so. Yes, but a lot more are going to be created. Are you going to be part of the team that is going to create these new jobs and be part of the new ecosystem? So we at least got to understand some of these things that are described on this page. And then beyond, there are some programming languages like Python, R, and Java. There are data management tools, SQL, NoSQL, and visualization. There are deployment tools and soft skills. Now, in these 2 slides, I focused mostly on technical tools and technical skills, but then there are a lot of skills around communication, collaboration, and problem solving that might relate directly or indirectly to AI implementation in terms of ethics and rules of engagement, which might be applicable to you as well, and which will help you transform your career to wherever you are to the new ecosystem. So sorry about this monologue, but I'll pause here. Please go ahead with your questions, and then we will do some hands-on exercises for a few minutes. I hope I'm still making some sense so far.
You are. I think we're all just a little conscious of the time right now. There's so many questions that could come out of this, but
okay, but please go ahead. We will, how about this? We will spend about 3 to 4 minutes on questions. I'll try to abbreviate the answers, and then we will move on to the last. I have a couple of more slides after this, very high level, and then we will do some hands-on exercises. And then it's purely optional for those of you ladies who can, spend a few more minutes. Feel free to stay on the bridge.
Well, I have one question. So there's a lot of different resources and courses in terms of, so I'm someone who has always learned on the job. I came into technology a very, very long time ago. I got into UX. I just had a natural affinity for it and learned everything, as I went. Now the job market is a little different. My experience counts for a lot, but the newer folks all require various levels of degrees to get in. And I'm wondering what you think about that for AI. It seems like, there is school to go to if that's something you can do right now. But for most of us, again, it's so nascent and it's changing so quickly. I think we're going to need to be learning, through events like this, and then following, whatever tutorials we can find as they come up, mostly professional to professional rather than school to student. And I'm just wondering about, the relevance of that. Basically I'm 51. I don't see myself going back to school anytime soon. So,
Okay, I understand. By the way, I wish I could trade ages with you, but
oh, you're adorable. Thank you.
I'm in my mid-50s as well. But yeah, so yes, and this gets more difficult, right, as we age, and our kids, we have to learn from them as well. So and thank you for giving me the cue to actually move on to the next slide. In terms of what do we need to stay relevant, and I think this you hit the nail on the head. You have to attend events like this. If you haven't been, you should, please. There are a lot of webinars, online as well as in person happening, not just in the Bay Area, but all around us, right? Be aware of those events. Try to attend a few. And as soon as you attend maybe a couple or three of them, you will understand that the underlying theme everywhere is going to be the same. So for me, I think I've attended 4 or maybe 5 seminars, big seminars this year, conferences, and almost everywhere the underlying theme was AI, just that's it. And I condensed all of that into those 3 bullet points right at the beginning. Remember, the transition from external hiring to internal hiring, and us moving away as a society from traditional role-based employment to gig-based employment is going to be the fundamental change of the next decade. That is number 1. Number 2 is the dynamics of how people and teams interact because of the pandemic. Many of our things are going to be remote. This is going to continue. And number 3 was AI is going to be at the forefront of all of this. In terms of focus, right, and differentiation of ourselves and products and services that we create, diversity, equity, inclusion, make tech purple, were very relevant. They will continue to stay relevant, but that was the language that people spoke yesterday. It is still relevant, right? But those were differentiators for yesterday, is how I would put it. Today, to be differentiable, you need to have AI in your ecosystem. As an individual, as an organization, you have to embrace AI. If you are working for a company that does not have an AI policy, it's too late. You need to. If you are going to come and interact with us as a business, and if we want us to be a business partner, our first question is going to be, what is your AI strategy? What is your AI adoption? Right? And so on. And what are the rules of AI engagement? So AI is current. And for the future, it's all going to be about sustainability, about recyclable resources, the green economy, carbon footprint, and all of that. And this is something that I learned from all of these seminars that I've attended. So if you want to differentiate yourself as an individual or as a business, you have to start talking that language, right? We are almost all at par with the DEI, equity, and make tech purple. We are almost now learning and trying to get to be at par with the AI. The future is all going to be about sustainability and the carbon footprint. So that also needs to enter our dictionary very soon, right? Whether it is at an individual level or at a corporate level. So these are the 3 transformations that have either happened or are happening or will happen in the future. That's one. Second, to your specific question, yes, with every new technology, there are a million ways to learn it. There are different layers to that technology. So let me just break it down very quickly. For AI, for Gen AI today to be available to the masses, the reason it is like this is because there is a huge ecosystem. There are some core companies, right, like OpenAI and Google and Apple that have built these foundational models. So in terms of employment opportunities, you could essentially be part of that underlying foundational ecosystem. So you go to Amazon Web Services or Microsoft or Google or OpenAI and seek directly with, work directly with them and build the foundation. That is typically, those are the somewhat nerdy kind of jobs, or jobs that are fairly low level in the sense that they are directly dealing with hardware or the infrastructure ecosystem, right? Building the core models. So that I would call that as layer 1. There will be, a lot of job opportunities there because this demand is going to grow. So that's one area you can focus on if you are, fairly technical and if that is your aspiration. Then there is going to be the second layer of companies that are providing vertical expertise across different domains. How do I customize ChatGPT for medicine or for real estate or for this or for that for my particular domain? So there will be hundreds, if not thousands of companies at the second layer. The first layer is just going to have a dozen or so because it's very expensive. For you to run one iteration of generative AI, and just FYI, it costs upwards of $200 million right now. So just imagine the amount of infrastructure cost that goes into building these large models. So it's extremely high. So unless you're a multi-billion-dollar player, it's next to impossible to build that kind of capability. So right now, I think there are 13 or 14 companies that do that. Gartner, I think, predicts that by the end of 2025, it will be down to about 7. So there might be some major, mergers, consolidations happening, acquisitions, or people just saying, "Oh, this is not for me." Anyway, at that level, right? In terms of companies. Second layer I mentioned are going to be the verticals that are going to derive content out of these basic models and build industry specific models, and I predict would be in the hundreds if not thousands. That is layer 2. So there's a lot of, again, employment opportunity there in terms of different things, and I already showed you in terms of software dev what are those areas, right? And then there is this infinite layer, which is the third layer that sits on top of the second layer, which is your own company, right? So maybe you can start exploring. This is what I do today, and these kind of platforms are available in my ecosystem, and maybe I can explore some of these newer tools to do things differently, right? So for those of you who are seeking to transition, either you transition in your current job role, and I think that's the best transition, by learning these new technologies and seeing how you can adopt this to make your output more effective, right? To make your whatever responsibilities you have, be able to deliver more, and in a shorter period of time. So I think that's the best place to start. If that option is not available, then you probably need to change. Look for another group, but probably within the same company, wherein such opportunities exist. So if I just were to go through this set of steps that I would recommend how to stay relevant, by the way, this thing has been inspired by, I was just reading an article on LinkedIn recently, and this is thanks to LinkedIn, at least the quote at the bottom is based on that. So, don't shy away from new technologies, be adaptive. Build your online brand, be creative, be unique, embrace the power of thought leadership and diversity. For those of us on the call right now, if you have not touched your LinkedIn page, for example, in the last few months, please look at that, right? More and more of these collaborations are going to happen digitally. So, and again, gig economy, like I mentioned, people reach out to you only if they know that you have a certain skill. For example, I work with an engineering team and we build products. Until recently, I didn't know that one of the guys in my team, who is actually the lead of testing, is actually really good at building these business intelligence reports. I had no idea, and then he said he worked in the finance industry decades ago, and he had the coolest reporting skills. I did not know about it, and now, thanks to the knowledge, he's being used by other teams as well. I think he's gotten a couple of promotions already. He still works as part of our team, but his compensation has gone up, and I think he has found more fulfillment in his job just because he's been able to use those additional skills that he was not able to use in the past, thanks to these kind of gig opportunities, right? Keep increasing your surface area. Which basically means, keep networking. There's a beautiful book titled Dig Your Well Before You're Thirsty. This was the first book I was, when I joined PricewaterhouseCoopers many years ago. This is the first book they gave to me saying, this is your Bible, read this. Before anything else, it talks about how you build active networking and be resilient, open to continuous learning, and attend events like this. Develop a growth mindset, embrace the change, leverage AI. It is a tool to make yourself better. Don't feel threatened. It requires a multifaceted approach to future-proof your career. So build an authentic online presence, nurture your interpersonal skills, embrace the change, and prioritize continuous learning. I think that's the essence of today's conversation. Today also happens to be coincidentally, and then thank you, Neha and Rachel, for continuously posting blogs on our LinkedIn page for BayOne. It happens to be National STEM Day November 8th. So it's a great coincidence that it's a reminder for all of us to focus on STEM, continue to focus on STEM. And I also borrowed a few of the marketing outreaches that BayOne has made over the last few months, and the concept of ikigai also comes into play here. And I think today was very relevant in that sense. We all have to juggle these four balls, if you will, in terms of what we like, what we love, right? What are our core strengths, what the world needs, and effectively what can we be paid for. And the intersection of all of this is going to give us, is the secret to a long and happy life. And as I mentioned today, AI is going to be a substantial component of the purple on the right, right? In terms of what the world needs and potentially what we can be paid for. And hopefully, if given how interesting some of those concepts are, definitely you'll love many of those things and make it a part of your core strength. And in terms of building new habits, this is another thing I borrowed from the recent BayOne marketing pitch, is about change. It's the power of compounding is very difficult to fathom. It's almost impossible to believe. Look at that, 1% change every day compounded 365 times. So over 1 year, making 1% change every day amounts to 37% change by the end of the year. 37% change, more than 1/3, just by changing 1% every day. But look at the scary part. If we get worse every day, if we give up the opportunity to learn new things. So if tomorrow I'm only 99% effective as today, then that compounded 365 times is a mere 3%. That is obsolescence. That is scary. So we have to continue to learn. We have to continue to adapt. AI is great and cool, but what makes us even cooler is that we are all human. There are many jobs out there that AI can never even dream to replace. But the use of AI, as that IBM quote mentioned, is definitely going to differentiate us and make us more effective, right? Things like human interaction, empathy, decision-making, physical dexterity, specialized skills, emotional IQ, artistic and creative usage of our talent. So all of these things will always be, valued. The only thing to remember is that even the most creative of artists are going to leverage AI. So even if you are an artist, you have to make use of these tools and see how you can be more effective in that field. Okay, so now we will move to hands-on exercises. Before that, are there any additional questions?
Unfortunately, I have to go, but this is really good. Thank you so much. And I'm so sorry. Can you tell us your name again?
Okay, my name is Suva Sharma, and I am part of the BayOne team. I do digital transformation here. Sorry, we rushed through the introduction part. My bad there. Yeah,
Oh, no.
and I did digital transformation, and I just type it in here.
All right. Thank you so much.
Absolutely, absolutely.
So Suva, are we concluding the workshop, or there's?
Now, I need, with your and Rachel's permission, if you both happen to be online, there are a few ladies on the call, and I know we're just down to about 10 people, but there are some very cool tools. I just wanted to show you.
Yeah, that'd be great.
Yeah.
Thanks, man.
So let me do that. And my apologies, ladies, if you had earmarked only 90 minutes for this. Hopefully, it's going to help everyone. So let's do that. I hope my screen is still visible. We will. Neha, are you able to see my screen? Oops. Did I lose my audio? Okay, everybody is giving me a thumbs up. So I'm assuming you can all hear me as well. Okay, so where is my, okay. So for those of you who have never used ChatGPT, the way you do that is you go to chat.openai.com. Okay. So I will do this very quickly. So that is the link for ChatGPT, the first one. And you have GPT 3.5, which is the default. That's the free version. There's also GPT 4. GPT 4 based ChatGPT, which I subscribe to. It's fairly nominal. It costs about $20 a month, but it has a lot of additional features. It is integrated with DALL-E, so you can create beautiful images as well. And then likewise, there is this product called Bard from Microsoft. So it's another engine that you can consider. So I'm just pasting those things. I'm also providing you another link. In the interest of time, there are some beautiful examples of how you can leverage ChatGPT. And let us start with that, okay? Let us start with that. If you look at the third link that I just shared with you, it's on Geek Flare. Just look at the kind of prompts. So essentially, whatever I write here on ChatGPT is called a prompt, right? And there is an entirely new stream of jobs that are completely focused on creating these prompts. And that stream is called prompt engineering. And I think somebody asked earlier, where do we start? The ecosystem is huge, but if there is one place simple place where you can, find information, the instructor of whom is Andrew Ng, a beloved instructor from Stanford, and I've attended some of his classes from many decades ago, and he's an awesome person. It's called deeplearning.ai. I don't know who asked this question earlier, but maybe it was Nicole. But that's another thing you can, this is one great place where you can start. You can go to deeplearning.ai. And when you click on it, you will get to a link like this, right? This is deeplearning.ai. And there are many courses that they have. And several of these courses are completely free, including generative AI for everyone, prompt engineering, and so on and so forth. So strong recommendation that you go and take a look there. And the Geek Flare page talks about the creative kind of prompts that you can write, right? Initially, you might think that, hey, on ChatGPT, I can just ask very simple questions. No, you can write an entire thesis there and ask ChatGPT to review it for you. If the file is too big, if it is more than 10,000 characters, you can even upload the file and ask it to review it, okay? So let us take a simple example here. Okay, create a system design. Create a system design for a SaaS application that emulates. I'm just thinking out loud, guys. What do we like? Uber? Okay, Uber. That emulates Uber. Also, describe all test cases, because I need to know how to test it, and draw a two-dimensional system architecture diagram. Okay. So we are asking the system to create a full SaaS application design that emulates Uber. It should describe all the test cases and also draw a two-dimensional architecture diagram. Never in the history of computing could you have done this and come up with an answer within 30 seconds. Just look at this. It is giving me all the components that constitute a SaaS application for Uber. Right? What are the factors I need to consider while designing such a system? What are all the test cases? Just look at that. Functional testing, performance testing, security, usability. I might not even have thought about it. I even asked for a two-dimensional system architecture diagram. So now it is calling DALL-E to create some of those diagrams for us. Let us see what happens. So it has invoked DALL-E. DALL-E is drawing the details of whatever it has described. It has to call out all the technologies, and there you go. It has all the components. I can actually even drill down into the picture and ask it to make refinements or explain it to us, right? Isn't that amazing? That is ChatGPT. Bard can do something similar. You can also play around with Bard. If you look at the third link that I provided, right, that talks about all these cool use cases, you can go there, copy paste some of these very unique, intricate examples of how you can leverage ChatGPT for your use case. And then OpenAI page actually has a lot more programming examples of what you can do, right? Really cool programs in any of these domains, like grammar correction, emojis, working with emojis and tweets and this and that. This is the workspace for OpenAI. Okay, these are called playgrounds. So essentially, you go there. There is some sample code. You can pull that, and you can play around with it. Because you have ChatGPT, you have also something called GPT-0. GPT-0 allows you to type or copy paste content and figure out if the content was generated by AI or if it was generated by a human. So that's also something cool. And finally, like I mentioned, maybe start off with deep learning AI. It has some cool courses. YouTube is always has a plethora of resources when it comes to learning. And Neha and I are also there for you as part of the Make Tech Purple program. If you have any questions anytime, feel free to reach out to us. I hope the session today was helpful. I hope it was relevant. And I hope whatever an hour and 53 minutes that you've spent with us was very helpful. It was a pleasure for me to be part of the Make Tech Purple program. And thank you, Neha, and thank you, ladies, for giving me this opportunity.
Thank you, Suva, for your time. This was really informative. Thank you again for lending your time. Ladies, thank you so much for joining. I hope that this learning session was able to demystify AI for you and give you some important insights. This was a Make Tech Purple initiative. The program aims to solve the gender gap problem in technology and create more opportunities for women and underrepresented groups. Thank you again for coming in, and have a great evening. Thank you, Suva, again.
Wonderful. Thank you, Neha. I'll actually stay on the bridge. Let me stop the recording right now, because I do see a few folks